When we wrote these simulations, we did everything we could to restrain ourselves from creating laboratory-based activities. Of course, the best way to do laboratory work is in the lab with your teacher and fellow students, exploring the laws of physics with real equipment. We didn't feel any need to compete with that important learning modality. But computers allow us to do something that wasn't available to me at all when I was a young person learning physics. They allow us to overlay a realistic physical scene with the underlying physics in a compelling way. So we aim to make these sims all about the real world, real bobsleds, real tetherballs, real tightrope walkers, things that are not necessarily easy to replicate in the classroom. Connecting physics to the real world is tough. I often feel that my students have two worlds in their head at the same time. One, the scientific world that they think about in class and when taking exams. The other, the real world, where they often still apply Aristotelian ideas in their thinking. Bridging these two worlds is the tough work of a physics teacher. We can help teachers and students by providing examples of real-world connections to each of our simulations. At CK12 Foundation, we have written 4 of these for each simulation. When you are in a simulation, you can click to page right to the slider-based questions, and then click again to page right to the real-world examples. The hope is that these provide bite-sized, compelling images and text. We have created a functionality where users can upload images and text of their own to help enrich our collection of examples. We hope that you'll consider uploading one of your own. The way to do this is to click on the plus button and then upload or drag an image and write out a title and supporting text, preview your work, and then hit done to submit it. So please consider uploading one of these real-world examples just to try it out. I also want to point out another way you can customize the simulations and add your own questions. The slider-based questions page, available in most simulations, some, as you may know, don't really have sliders. But this slider-based questions page gives students a chance to explore the answer to questions about the physics behind a simulation by adjusting the sliders and checking their work. You are invited to make your own slider-based questions. You start by clicking on Create New Question. You can type in your question and a description below it. Since students all over the world are reading these, it's a good idea to be as clear as possible when writing the question. You then select slider answers that match the correct answer. Note that one possibility for each slider is any, meaning that any value for that slider will allow a correct answer. This is most useful if the slider in question doesn't actually pertain to the question you're asking. You can then save your question and we will publish it for you. And as always, we are eager to hear your feedback and critique of the simulations so we can make them better. Thank you for watching.